Chapter 7, Example 3. Create a regression model for the provided data on 2010 American League Baseball game attendance and total runs scored. This one just says create the regression model, so that's all we really need to do. We're not going to have to write anything up further about it. It doesn't say like discuss it, or is on the last problem where it said how can we use it, so it wanted more of an explanation there. So this one just wants the model. Now we've discussed this example before. We've discussed the distribution, so we know the scatter plot, what the scatter plot will look like. I'm going to move it up here so we can look at it a little bit more closely. Keep it right next to our data. We always like to have a picture shown with our explanation. And there we go. We know by now how to make this scatter plot. If you don't, you need to watch the earlier videos for that. So now the scatter plot. Okay. It looks linear. It's maybe like a moderately strong. We've discussed that before. It's positive. There could be a couple outliers. We discussed that before. The one at 660 or so is not influential. The one at 510 could be influential, so we'll talk about that. But we'll still proceed because it says create a regression model. I'm not going to give you a question. It says to create a model, and then at least on the test I won't give you one like that. There could be homework problems that do that where you would stop, but on the test, on the AP exam, definitely if it asks you to do a model like that, you are going to do a model. Check the conditions always and say proceed with caution if you're not happy with something, but always do the model if you're asked to. So the scatter plot of total runs scored in a year we don't know this is a year specifically from the instructions, so we'll leave that out. So scatter plot of total scores, runs scored, and game attendance is moderately strong, positive, and fairly linear. Okay, now let's proceed with the rest. Conditions, quantitative data. Both game attendance and total runs scored are quantitative. And the association is linear. Okay, looks good. But now about the outliers. There are two possible outliers. At about 510 and 680. The outlier we want our context here, so let's make sure we specify that this is runs. The outlier at about 510 runs may be influential. I will proceed with caution. But fit a linear regression model to the data. Okay, you always need to state what you're about to do, so I'm going to do a linear regression model. I'm going to proceed with caution, but I will do this model. Always state the model. Now, we're not going to have to do this by hand. I'm not going to find the correlation and then find the mean and all that stuff. We're going to use the calculator to do this. And I'll show you the results. I'm going to explain what happens. You're going to create a new page, control document, just like we've been doing. Do a calculator page, number 1. Okay? Then you're going to do menu, statistics, stat calculations, just like we did for one variable statistics. And when you look down, you'll see the 4th option, which is your linear regression. We've actually used this before. Type in the X variable, which is total runs, the Y variable, which is attendance, and graph this. Okay, and when you come up with this, we have everything provided here. So we know attendance is our explanatory or response variable, so we put that there, attendance hat, equals our y-intercept, which in this case, if you notice, it says a plus bx, so it tells you which it is. A is what goes first, so negative 1,673.8. So if there were no runs scored by a team, you would expect them to have negative 10,000 in attendance. This is one of those examples where it doesn't really mean anything. It's there, you need it for the graph, but you're not going to say we would have an attendance of negative 10,000. And so we increase by 54.198 people per every run scored. Now, we should look at the regression, but we haven't exactly, or the residual plot, but we're going to get that in the next example. I'll show you how to do that on the calculator. what normally happen is we can take that scatter plot and just put the residual plot below it and look at it, and we will look at how to do that shortly.